Hello, this will be the beginning of chapter 1.6, other types of functions. Before I start with the definitions and concepts for this chapter, I would like to review how to add fractions. There's different methods you can use to add fractions, but I will choose to use this cross-multiply method, or some students call it butterfly method. If I have a over b plus c over d, I will cross multiply starting with my numerator on my first fraction, a times c, that's my first term, b times c, that's my second term. Whatever sign I have, I keep. If it's adding, it's adding. If it's subtracting, I'm going to make this a subtraction symbol. And then you multiply the denominators to get your denominator, BD. Let's try it to add 13 over 2 plus 24 over 5. I cross multiply starting with my numerator. 13 times 5 is 65. I keep my sign plus this method only works for addition and subtraction. Multiplying is straight, and dividing, we're going to review it in the second slide. 2 times 24, that is 48, divided by 2 times 5, which is 10. This will give me 113 over 10. If you can simplify your fraction, then you simplify, but 113 and 10 don't have a greatest common factor. They can only be divisible by 1. That's their greatest common factor, which keeps the fraction as it is. We cannot simplify. It doesn't matter if you have variables. Let's look at their second example. 3px over 2 plus 4p over 5x. Same method. I cross multiply starting with my numerator on the first fraction. I will have 3 times 5, 15. I keep the p, x times x, x squared. Make sure that you keep the symbol, plus 2 times 4p, that's 8p, divided by 2 times 5x, that's 10x. Again, in this case, we cannot reduce. I know that 15 and 10 are both divisible by 5, but that 8 is not divisible by 5. And I know x squared and x can be reduced, but this term doesn't have an x. So this is my simplest form for this rational expression. Now let me go to review dividing fractions. To divide fractions, this shouldn't be, it's not a property or a formula. There's different methods. You can use the sandwich rule when you have a fraction on top of another fraction. I will use the cross multiply. If I have a over b divided by c over d, I cross multiply a times c, put it in my numerator, b times c, and put it in my denominator. This only works for division, only for division. Let's try it. I'm going to divide 13 over 2 by 24 over 5. 13 times 5, let me keep the blue color. 13 times 5, we're not dividing, we're multiplying. 13 times 5, that's 65. I got it from it was the same number as the last problem. Divided by 2 times 24, 48. And again, normally we simplify, but 65 and 48 don't have any other greatest common factor than 1. And this is the simplest form. If I want to divide 3px over 2 by 4p over 5x, cross multiply, that will be my numerator. Remember to start with the numerator in the first fraction. 3px times 5x, we had already done it. It was 5px squared divided by 2 times 4p, 8p. And normally we reduce. We can reduce here p divided by p, that's 1. And my final answer is 15x squared divided by 8. This is the simplest form for that. I would like to go over a little bit of vocabulary on what is a rational expression. I'm assuming you already know what a fraction is. A rational expression is a quotient of two polynomials. In other words, it's a fraction where you have a numerator and a denominator that are polynomials. You have variables on both the numerator and the denominator. And just so you know, the numerator, it's what we call the number on top of your fraction, and the denominator, it's what we call the number on the bottom part of your fraction. The numerator is the part that we're focusing on, and the denominator is the whole of your fraction.